Good evening, all.
Good evening, sir.
I am Pramod Gawal, Research Scholar, Department of Chemical Engineering, IIT Guwahati. I am going to take assignment practice session 11 on mass transfer operation 2, week 11, assignment 11 on adsorption and ion exchange chapters. I hope all of you have gone through the week 11 lectures.
Yes, sir.
So I am going to take 13 questions. Some of them are MCQ and some of them are numericals. So starting from the MCQ ones, what is the major use of the carbon molecular sieves, CMS in short forms? This is a adsorbent. The option are given to separations for lower hydrocarbon zeolites. Option B, it's the adsorption of organic from the drinking water. C, separation of the air to the produce N2, and D, removal of the organic from gas streams. Anybody know the answer of use of
This
carbon
is C
molecular sieves?
option.
Okay, C, right. Separation of the air to the produce N2. This means to separate the lower hydrocarbons, use a zeolite or ZMS. Then adsorption for organic compound from the drinking water, use the activated carbon as a adsorbent. And for the removal of organic from the gas streams, use a polymerase adsorbents. Question 2. If the adsorption rate of the solute is infinitely fast and irreversible, the thickness of the empty jet would be, here this is a fixed weight. This is a empty jet. Empty jet means mass transfer zones. You can also can say adsorption zones. When adsorption rate of solute is infinitely fast and irreversible, thickness of the MTP would be 0. So these zones will be diminished if adsorption rate of solute is infinitely fast. All of you getting this ones?
Yes, sir.
Moving to the question 3. If the length of the unused bed LUV is more, if the mass transfer zone is, here unused bed means some of the adsorbent part did not use, sorry, do not use to adsorb the adsorbate. That's called the unused bed. So here I ask the length of the unused bed is more if the mass transfer zone is. It will the while. Question 4. The breakthrough point is decreased by. Option are increase the particle size of the adsorbent, increase the concentration of solute in the feed, increase the flow rate, decrease the beta depth, and all of these above. Here breakthrough points mean, suppose here adsorbents. Some of adsorbate adsorb on the this adsorbent. So initially, this is the mass transfer zone. After that, some of the adsorbate goes to the downsides and adsorb on the new adsorbent. But at the end of the column, end of the fixed bed column, some of the effluent comes out to the bed. That's known as a breakthrough. So breakthrough point is decreased by option are given here. The answer of question 4 is all of these above. Yes. All these factors would help to decrease the breakthrough points. All of you got this one.
Yes, sir.
Question 5. Adsorption capacity of regenerated bed compared to the fresh bed is generally. There are the three types of three method for the regeneration of the adsorbent. One is the pressure swing adsorption, ESA short form. Then temperature swing adsorption, ESA, and third is displacement of adsorb. Displacement of adsorb or purging of the adsorbent. These are the types of or method for the regeneration of the adsorbent. So here in this question asks the adsorption capacity of regenerated bed compared to the fresh bed is generally. Anybody tell the answer of this question? Option are given slightly less, slightly more, half that, half of that of the fresh bed.
Option A option, sir. A option.
A slightly less, right? Question 6. How is the breakthrough concentration defined for the adsorption in a packed bed? In previous slide, I explained for the fixed bed. Here, answer for the packed bed. Based on that explanation, can anybody tell the answer of these questions? Means breakthrough concentrations definition for a adsorption in a packed bed. It is a minimum detectable or maximum allowable concentration in the effluent from the bed. It is approximately half of the solute concentration in the feed, and C is the maximum solute concentration in the effluent, and then none of them. Anyone? It's simple one. Yes, anyone?
It's option A.
Yes, right. It is a minimum detectable or maximum allowable concentration in the effluent from the bed. Question 7. Ion exchange reagents is option are given linear low molecular weight. The organic polymer with porous structure is soluble. Answer of question 7 is C. Organic polymer with a porous structure. Moving to the question 8. Ion free water coming out from the exchanger is known as. It is a simple one. Option here given. Can anyone tell the answer of these questions?
Option A. Option A. Portable water.
No, wrong. If we remove the ions from the waters, that's called the DI water or demineralized waters. Here is removing ion from the waters. That's known as the demineralized waters. Getting or not?
Yes, sir.
Question 9. In PSA systems, pressure swing adsorptions in the regeneration method. Regeneration of the adsorbent. In these systems, adsorption of the solute occur at the higher pressure. Is this statement true or false? If someone know, tell the answer. Yes.
It's A option is true.
Okay. Okay. Why? Why is this statement is true? Because rate of adsorption increases with increasing the pressures. So it's mostly prefer at the higher pressures. Now question 10. Adsorption occur at lower temperature in a temperature swing adsorption system. This is also regeneration's method of adsorbent. So is this statement true or false? The
It's
solution,
true.
this statement is not true. For TAC systems, it is mostly preferable at the lower temperatures. Now starting the numerical questions. The velocity of MTZ mass transfer zone for adsorption of the solute in a packed bed is 5 centimeter per minute. The length of the bed is 120 centimeter. The equilibrium time is 26 minutes. I have to calculate what is the thickness of the MTZ means length. What percentage of the bed remains unused at the breakthrough. All of you try to solve these questions. Here given L 120 means length of the bed is 120 centimeters. Uh, PE equilibrium time given 26 minutes. Velocity given 5 centimeter per minute. Now first we have to calculate breakthrough time in TB. And denominated by TB. So you know the formula L to velocity into TB. So TB L. Put all the value in this formula and know the breakthrough times 120 divided by 5. So 24 minutes. This is a breakthrough time. Now, the first part, what is the thickness of the empty jet? Means length of empty jet. Velocity into equilibrium time minus PB. Velocity given 5, T 26 minus TB calculated 1 24. So 10 centimeters. Right.
Mhm.
Anna, you got this one 10 centimeters.
Yes, sir.
Now, second part, what percentage of the bed remains unused at the breakthrough? Calculate the percentage of bed remains unused at the breakthrough. Ten divided by initially 120 into 100. 8.83%. All of you got this one?
Yes, sir.
8.3%.
Yes, sir.
Now moving to the question number 12. The statement given, an experimental pack adsorption column of 0.5 meter bed depth is used for breakthrough study of a dilute vent streams having 0.02 mole fraction of the volatile organic. The breakthrough curve is symmetric and effluent concentration is 0.01 mole fraction at 60 minutes. It is also found that it takes the 15 minutes for the effluent concentration to the increase from Y is equal to 0.00042 to 0.0196, that is the 2% to 98% of the incluent concentration. What is the length of the empty jet in centimeter? Then what bed height would you recommended if 90% of utilization of the bed is to be achieved under the same operating condition? And then what is the breakthrough time for this bed? Here we have to calculate first what is the length of the empty jet. After that, in second part, if 90% of utilization of the bed, then we have to calculate the bed height. Then at same operating condition, then I have to calculate the breakthrough times. PB, right? Here length. Here TB given 60 minutes. Bed length given 0.5 meters. Convert into the centimeters. See? Right. Now, if the mass transfer wavefront is symmetric and Tm is a sorry, 1 minute, sorry, here is it, sorry, Tm. Tm is the time when the effluent from the bed attains a C 0.5. So first to calculate the velocity L by yeah. Means these times to reach the this is a breakthrough curve means breakthrough point to reach the C divided by C naught is equal to find 5 the velocity. Now if it takes the 15 minutes for the mass transfer wave front to the move through its the on lane comes C naught equal to 0.02 to 0.98. So length of MTZ velocity into to this time Ts. All of you got clear this one.
Yes, sir.
So first we just calculated length of the MTZ. Now L U B 1 minute length of LU means length of unused bed at the breakthrough 12.5 to 6.25 centimeters, assuming a symmetric wave front. Assuming here I also mentioned breakthrough curve is a symmetric wave front. In second part, said that for the 90% of bit utilization, 90% bit utilization L minus LUB so LUB just calculated 6.25 6.25 62.5 centimeter. This is a long bed. We have to use long bed. So initially it was present 50 centimeters. With just calculate the bed height when 90% of utilization of bed. After that, we have to calculate the breakthrough time. Question. length and velocity. 62.5 minus 6.25 divided by 0.833, 67.52 minutes. Breakthrough time is 67.52. All of you got this one? Or
Yes, sir.
someone else others answer? Students, all of you got this one? Forgot the
Yes, sir.
okay. Moving to the last questions. 13 one. Statement given: water containing 120 ppm calcium science is to be treated with the 8% of DBB cross-link resins in the Na plus and form to remove 90% of the calcium ions. The resin has an exchange capacity of 2 equivalent liters. This is the concentration. You can see normality. Calculate the amount of resins. Calculate the amount of resins required to treat 10 raised to the power, sorry 10 meter cube of the waters. Here is the equilibrium constant given, or you can say selectivity coefficient. Allow me try to solve these ones. So all of you follow to me. Equilibrium constant is this one given. For resin phase, the total concentration of oil exchange sites C for 2 equivalent liter. Total concentration of ions in a solution expressed as A plus plus this one 150 ppm convert into gram per liter, so 0.12 gram per liter. So convert this unit in gram equivalent per liters, because here given the unit of concentrations equivalent per liter. Gram equivalent equal to weight divided by equivalent weight. Weight. So equivalent weight, to calculate the equivalent weight, molar mass number of valence. 0.12 Number of valency of the science 2, and molecular weight means equivalent weight or 14. Molecular of the calcium is 14. So, 0.006 equivalent E. All of you got this ones.
Yes, sir.
Here mention the 90% of the calcium ions is removed at the end of equilibrium constants. Those of the calcium ions remaining in the water is 0.05 means 5%, 0.006, 0.0003 equivalent per people. This one is a C. Is the C in a solution in a reagent phase. Now equivalent reaction of the calcium ions in a water at equilibrium EXD equal to 0.0003 to 0.006, 0.05. Right, that's the equilibrium fraction of calcium ions in a water at equilibrium. Now, YD is the equivalent fraction of the calcium ion in the reagent phase. To calculate this ones, we have to use this formula YD to 1 minus YD here into equilibrium constants A already given 2.6 into the xt whatever 1 minus xt. C given bar gave the region phase given, this also given, xt gave calculated. Now calculate the YD. YD is equal to 0.8 6, 5, 7. All of you following or not?
Yes, sir.
Now the total amount of calcium ion in a solution. 0.1 initially given is the 120 ppm convert in gram per liter into volume given the 10 meter cube to convert into the liter 10 dash log or liter. Convert into the gram equivalent 60 equivalent of calcium. Now iron remove 60 into 95% is 1 gram equivalent. If m kg of resin used, the question asks calculate the amount of the resin required to treat the 10 meter cube of the water. N kg resin used. The quantity of exchange sites equal to OM equivalent. Now YD we calculated this fraction of 0.86 is 0.8657 of the exchange sites are now occupied by the calcium ions. Price M into 0.8657 to 50 cents. M is equal to means quantity of reagents 33 kg. All of you got this one?
Yes, sir.
Means 33 kg of resin used to treat 10 meter cube of the waters. I cover the all questions. 13 questions. Anybody have doubt? Please ask.
No doubt, sir.
Okay. So thank you all. I close the today sessions.
Thank you, sir.
Okay. We will meet on next Tuesday on last chapters asking crystallizations on same day. Thank you.